Hey everybody! Today's practice problem comes from Principles of Microeconomics by Gregory Mankiw. We work with the 6th edition and we're going to be doing chapter 14, problem number 12. The problem begins by saying, an industry currently has 100 firms, all of which have fixed costs of $16 and average variable cost as follows, and then it gives the relationship between the quantity produced for a single firm and average variable cost that looks like this here. And then the first part of the problem says, compute marginal cost and average total cost. So the first thing that we want to do is think about, well, what are the formulas? What are the definitions of these costs? And just as a reminder, we have marginal cost is equal to the change in total cost divided by the change in quantity. Because marginal cost, if you recall, is just the incremental cost incurred from producing one more unit. And so this formula makes sense when change in quantity is 1. We're just looking at by how much did total cost change. And then our other formula that we have, average total cost, is equal to total cost divided by quantity. So this really highlights the difference between marginal cost and average total cost, right? So we can think about what information we need in order to calculate each of these costs, and it seems like, well, we have quantity, right? That's just what's given here. But we need some measure of total cost, and then we can just use these formulas to figure out what these other costs are. So we can think about what we have. We have average variable cost. So, okay, so what other formulas do I know? I know, for example, total cost is equal to total fixed cost plus total variable cost. Still don't have either of those directly. But I could have total fixed cost because I was just told that this was 16. But then I would still need total variable cost. Well, I know that average variable cost is equal to total variable cost divided by quantity. So some simple arithmetic is going to tell us that our total variable cost is equal to our average variable cost times quantity, just multiplying both sides of this by quantity. And that's helpful to remember because you can use these formulas forwards. You know, if you have total variable cost, you can get average variable cost. But you can also use them what I would call backwards. And that if you have average variable cost, you can also scale that up to get total variable cost. So now we see this is something that we can do. So we can get total variable cost, we know total fixed cost, we can get total cost, and then we can get these guys. So you just have to use your cost formulas to think about what plan of action really makes sense. So here we could say total variable cost, and again that's just going to be average variable cost times quantity. So we're just going to see 1 times 1 is just 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and 6 times 6 is 36. And we also know that our total fixed cost, we were just told in the problem, says it currently has 100 firms, all of which have fixed costs of $16. So we know that this just has to be 16, 16, 16, 16, 16, and 16. So now we can just add these up to get total cost. So 1 plus 16 is 17, 4 plus 16 is 20, 9 plus 16 is 25, 16 plus 16 is 32, 25 plus 16 is 41, and 36 plus 16 is 52. So now we have the change in total cost that we need. And so we can calculate marginal cost. Say, well, we can think about the marginal cost. Normally we say we can't fill in the marginal cost of this first quantity because we don't have anything to compare it to. However, what we would be comparing to in this case is a production quantity of 0, right? And we can think about, at a production quantity of 0, what do our costs look like? And by definition, at a quantity of 0, our total variable cost is 0. But then our total fixed cost, at least in the short run, is still 16, because in the short run, we've paid those fixed costs and we can't get away from them even if we're producing a quantity of 0. So we would then know that our total cost at a quantity of 0 is 0 plus 16, which is 16, making, of course, our change in total cost, well, we would go from 16 to 17 for a change of 1. So the marginal cost of this first unit is actually that change in total cost of 1 divided by a change in quantity of also 1. So our marginal cost of this first unit would actually be 1. And notice here that we've made this easy and that quantity is always changing by 1 unit. So when we calculate marginal cost, we're always going to be dividing by 1. So we can just think about, in this particular instance, the marginal cost being the change in total cost incurred. So we can keep doing that, and we can notice that the change in total cost, going from the first unit to the second unit, is 3, and then 20 to 25 is 5, 25 to 32 is 7, 32 to 41 is 9, and 41 to 52 is 11. So we would get marginal costs that look like this. Sometimes you'll see in your textbook, sometimes the marginal costs are written between two quantities. So the marginal cost of the first unit means the marginal cost in going from a quantity of 0 to a quantity of 1. Sometimes that'll be written between the quantity of 0 and 1. And then this 3 would be written between the quantity of 1 and 2, and so on and so forth. So you want to make sure that what you're doing is consistent with the way it's presented in the textbook, but the idea is still the same. So this is our marginal cost. And we could also do average total costs here by just taking our total cost numbers and dividing by quantity. So for these, I had to bring out my trusty iPhone calculator to make sure we're not making a mistake. So average total cost at a quantity of 1 is just easy, right? That it's just going to be 17 divided by 1, which is 17. The second one's also pretty easy because it's just a total cost of 20 divided by 2, which is 10. But then we get 25 divided by 3, which is, 8 in the third. And we can make sure we're doing that right. 25 divided by 3, it's about 8.3. And then we have a total cost of 32 divided by, a quantity of 4. That's just going to be 8. Then here we have a total cost of 41 divided by a quantity of 5. Again, that's going to be a little bit more than 8, but we can do that. We can say 41 divided by 5. It gives us 8.2. And then we have a total cost of 52 divided by a quantity of 6, which gives us about 8.7. So we get average total cost that looks something like this here. And this is perfectly fine to do. One thing you could note is that you technically didn't need to calculate total cost in order to get marginal cost, because marginal cost by definition is incremental cost. So fixed cost doesn't actually factor in to marginal cost. Marginal cost only has a variable cost component. So you could have also noticed that this marginal cost is also the change in total variable cost divided by the change in quantity. And you would notice, for example, change from 1 to 4 for a quantity change of 1 is 3, 4 to 9 is 5, 9 to 16 is 7, and so on and so forth. Part B of the question asks, the price is currently $10. What is the total quantity supplied in the market? So I'll just write down somewhere here, I'll put P equals $10, just so we don't forget it. And then we can think about where we want to go from here. So we notice it says an industry currently has 100 firms. So I could add to that. I could just say N equals 100, where N is just the number of firms. And I could think about what implications that has for what type of model we're looking at here. And if we have 100 firms in an industry and those firms are producing reasonably similar products, we most likely have a competitive market that we're dealing with, right? And we can think about, well, once we know we're in a competitive market, that means that the individual firms are taking the market prices given, and that they're maximizing profit by producing the quantity where that price that they're taking is given is equal to their marginal cost. So we can think about, in order to determine supply, what quantity for each firm is profit maximizing, and then we can just aggregate up for all the firms in the market to figure out market supply. So we say here, the firms are going to set their individual quantities where price equals marginal cost, assuming, of course, that they're not going to shut down. As long as their price is covering their average variable costs, they're going to produce some positive output. So we're just going to check that once we find out what this optimal quantity is. So we could say here, okay, let's see what quantity exists where the price of 10 is equal to the marginal cost. And what we see is that we don't have anything where that's exactly true. So, well, that's weird, because we have this rule and now we can't use this rule. Well, we can still do the problem by thinking about why this rule exists, right? So if you think about it, this rule is profit maximizing because the price is the additional dollars in you get for selling one additional unit of output, right? Because in a competitive market, you don't have to lower your price in order to sell more. So if you sell one more unit of output, you just get an extra $10. And then the marginal cost is just by how much you've added to your costs. So we could ask a series of yes or no questions here. Does the firm want to produce this unit of output? Yes or no? And for this first unit of output, say, well, this first unit of output brings in $10 and adds $1 to our cost. That seems like a good trade-off, right? That's going to get me an incremental $9 in profit. So yeah, I want to do that. That's going to add to my profit. And then we can ask, do we want to produce this second unit? Well, this second unit, again, brings us $10, but adds $3 to our cost. So I get $10 and I pay out $3. Yeah, that seems like a good trade-off. That's going to add $7 to my profit. I want to produce that unit. We keep doing that. We say this third unit brings in $10, adds $5 to our cost. Yeah, that trade-off is still good. This fourth unit brings in $10, adds $7 to our cost. Still, that's going to give us an incremental profit of $3. It's going to add to our profit. This fifth unit brings in $10, costs us $9. Yeah, that still makes sense. But then this sixth unit brings in $10, but adds $11 to cost. You say, oh, no, I don't want to produce that sixth unit. That's going to subtract from my profit rather than add to my profit. So we can see from that that the firm is going to want to produce, or has this profit maximizing quantity of 5 units, because it was profitable to keep producing up until we hit this 6th unit, and then we said no. So you can think about how that relates back to this rule here, right? Because it seems a little bit at odds with what we were told up front. But what you can say instead is keep producing as long as the price, or what you're taking in, is at least as big as marginal cost. And technically speaking, if we had a situation where we had a unit of production where price was exactly equal to marginal cost, we would technically be indifferent between producing and not producing that unit, because it wouldn't subtract from our profit, but it wouldn't add to our profit either. But we generally make the assumption that if we're indifferent between producing and not producing a unit, we just go ahead and do it. So that really lines up with this profit maximization condition here. But if we were to apply this rule, keep producing as long as price is greater than or equal to marginal cost, we would say keep producing as long as $10 is greater than marginal cost or equal to it. And that would tell us to keep producing, and then stop, right? That we wouldn't produce this 6th unit here. Technically speaking, once we've determined that 5 is the profit maximizing quantity for a firm to produce, we have to double check and make sure that that profit or that situation is actually enough of an incentive to get them to produce at all. So because we're in the short run, these fixed costs have already been paid. They're not recoverable. They're what's called sunk, right? So in the short run, if this firm is actually going to produce this 5 units, it has to be the case that producing 5 units is better than producing nothing. And we can see that by saying, well, is the price that we're getting at this quantity of 5 units, of course that $10 that we're taking is given, does that at least cover our average variable costs? Are we at least working to pay back our fixed cost even if we're not making a positive economic profit overall? And we can see that that price of $10, if we were to look over here, we're comparing that to an average variable cost of $5. So yeah, we're clearing that threshold where we're saying, yeah, we're at least getting a price high enough to cover our average variable costs. So yes, we want to produce as opposed to shut down. So now that we have the amount that an individual firm is going to supply at a price of $10, it's reasonably straightforward to then figure out what market supply would be at a price of $10. Because we were told that there are 100 firms and that each of those firms faces this set of costs here. So each of those firms is going to find it profit maximizing to set a quantity of 5 units. So then we could say that our market quantity, call that big Q for market quantity, as opposed to lowercase q for individual firm quantity, is just going to be how much one of these firms is producing times how many firms there are. So our market supply at a price of $10 is going to be 500 units. The first question in the next part of the problem reads, as this market makes the transition to its long-run equilibrium, will the price rise or fall? And we can think about what we know here that's helpful to, get us to the point where we can actually figure that out. So as we said before, this situation that we described here is a short-run situation. We said that when we were producing a quantity of 0, we were still incurring this fixed cost of 16 because that fixed cost was sunk and not recoverable, and so on and so forth. So we want to think about what we need to know to analyze what the transition from the short run to the long run is going to look like. And the main difference in this particular context is that in the short run, the number of firms is fixed. So it's fixed at 100. In the short run, you're either in the industry or not. You can't change that. You can shut down, but you can't fully exit. You also can't enter. Whereas in the long run, firms can enter and exit. So in the long run, the number of firms is no longer fixed. And we can think about, well, what makes a firm want to enter or exit? And that answers economic profit. So what we see is that firms want to enter when there are positive economic profits to be made, and firms want to exit when there are negative economic profits to be made. And that entry and exit is actually going to change market supply, which in turn is going to change the market price. So in order to figure out what's going to happen in the transition from the short run to the long run, we need to understand whether in this short run equilibrium, each of the firms is making a positive or negative economic profit. And we can say we have a formula for profit here. You can write profit as total revenue minus total cost. We can also write this, it's usually more helpful to think about in this way, as quantity times price minus average total cost, because we know that quantity is always greater than or equal to 0, so we can tell pretty quickly whether a firm is making a positive or negative economic profit by just comparing price and average total cost at the quantity that the firm is actually producing. So we said here, each firm is going to produce 5 units, and we can compare a price of $10 to an average total cost of 8.2. So we could see here that the profits in the short run, if I was going to say short run profit, pi sub SR perhaps, that this is just going to be a quantity of 5 times a price of 10 minus an average total cost of 8.2. And I'm not, I could go and calculate that and figure out what specific number it is, but I actually don't need to, so I'll hold off on that. But I can definitely see that this is greater than 0. And because this profit is greater than 0, in the transition to the long run, we're going to see entry. And we can think about what that's going to look like, because what we ultimately want to know is, will the price rise or fall, right? So we can think about the effect that entry has on the market. And to do that, we need to think about our market supply curve. So if we were going to think about a market supply curve, here you have quantity, here you have price. We have a market supply curve that's upward sloping like this. And we said that one of the determinants of supply was the number of firms in the market. And when the number of firms in the market goes up, supply increases. And an increase in supply looks something like this here, right? If I were to put a demand curve on this, then it looks like this. We could do a little bit of comparative statics analysis and notice that entry is actually going to move us from a short run equilibrium here to a short run equilibrium here, and we're going to see a decrease in price. So we can take this one step further and say that this entry is going to decrease price. The next part of the question says, will the quantity demanded rise or fall? Well, we can see here the quantity demanded, not surprisingly, is given by the demand curve, which didn't shift. So we're going from a quantity demanded at this price here to a quantity demanded at this price here. We can see that that's an increase, that the lower price is going to cause the quantity demanded to increase. And then we're asked, will the quantity supplied by each firm rise or fall? So we can think about, well, what information do we need in order to answer that question? Well, our firm is behaving according to these profit maximization rules, right? So if we're going to set quantity where price is equal to marginal cost, and our price is going down, we can think about what that implies for individual firm supply. Well, as it turns out, if we're going to think about what a marginal cost curve looks like, marginal cost is upward sloping. So what we see is that when we have a decrease in price, that's going to lead to a decrease in the quantity supplied by each firm. And this is just a fancy way of showing that individual supply curves, individual firm supply curves, also slope upwards. So lower prices are going to result in a smaller quantity supplied by each firm. And we can just see that here. Once we go from P1, it was profit maximizing to produce a quantity Q1 star here, because that's where price is equal to marginal cost. When the price lowered to P2, the firm would only want to produce a quantity Q2 star, because that's the point at which price P2 equaled marginal cost. So we can say over here that the quantity supplied by any individual firm, notice that I called this little q sub s for individual firm supply, is going to decrease. The last part of the question asks us to graph the long-run supply curve for this market. And we can think to do that, we can think about what we know about long-run supply. And what we know is that when all the firms in a market have the same cost structure, long-run supply is going to be horizontal or perfectly elastic. If different firms in the market had different cost structures, long-run supply might be slightly upward sloping, but it's still trending in the direction of horizontal. So we know, as a starting point, if we were going to graph long-run supply, we know that we have a horizontal line here because we know we were told that all the firms have the same costs. So we could just say, S sub LR for long-run supply. And what we really want to understand then is at what price this horizontal line is at, right? What price is this market going to keep coming back to? And we can call this P star sub LR, but we could also do a little bit better and think about what price numerically this is actually going to be. And one of the things that we see, just because of this fact that whenever short-run profits are greater than zero, we see entry, which pushes profits down, because you'll notice lower prices mean lower profits for each firm, and vice versa. So if we had short-run profits that were less than zero, we'd see exit. We'd see all this going in reverse. We'd see prices go up, quantity supplied go up, profits go up, and so on and so forth. So it must be the case that this long-run equilibrium, and this is a key result for competitive markets, that the long-run equilibrium in a competitive market is where firm profits are equal to zero. Remember, economic profit, not accounting profit. So they're just not getting anything extra or special. They're getting a normal rate of return on their investment. So we can think about, well, where are economic profits going to be zero? Well, again, come back to our handy-dandy way of looking at profit here. Economic profits are trivially going to be zero when the firm's not producing anything. That's not particularly interesting. But they're also going to be equal to zero when price is equal to average total costs at that profit maximizing level of production, right? So we can think about where that's going to happen. And as it turns out, if we think back to the shape of our cost curves, I can draw a very quick little diagram for you here, just reminding you what cost curves look like. In general, we see marginal cost is upward sloping, and then we see average total cost that looks like this, and it intersects with marginal cost at the bottom of this U at its minimum, right? And what we notice is that the point of zero profit is right at the bottom of this average total cost curve, because the firm is maximizing profit by setting quantity at the point where price is equal to marginal cost. But then if the firm is getting zero profit, marginal cost also has to equal average total cost. So what we end up seeing is that our long-run price is the price that just hits the bottom of this average total cost curve, because this long-run price is where price is going to equal marginal cost because the firms are maximizing profit, but price is also going to equal average total cost because the firms are making zero economic profit. And say, well, that's, where this is going to happen is exactly here. So then we could say that this is the associated long-run equilibrium quantity as well. So we can use our cost numbers to think about where this is located, right? So if I'm looking here, one of the things that I notice is that I'm looking for a place where marginal cost equals average total cost. That doesn't happen perfectly, right? That there's no place where these are exactly the same. And that's just a function of the fact that we're dealing with discrete units of production. If we had fractional units we could stick in here, we could find a point where they're exactly equal. But we can also notice that the long-run price is where average total cost is minimized. So we can look at it that way as well. And we can say, well, average total cost is minimized at a quantity of 4. So we could say in the long run, A, that each firm is going to be producing 4 units, but also that we can figure out what the long run price must be, because if firms are making zero profit, it must be the case that price and average total cost are the same. So we can therefore conclude that this long-run price is equal to $8 and that our long-run supply curve is horizontal at a price of 8, with larger points or larger quantities on this long-run supply curve not corresponding to each individual firm producing more, because we know that in the long run, firms are always going to be producing a quantity of 4, right? But further out points on the quantity axis here instead refer to just larger number of firms being in the market.